Welcome to this new video. I guess you're here because you're tired of pouring yourself out of all your efforts in solving. Today isn't just another day to talk about the same old tips. It's a time for a shift. A seismic shift that pulls you out of your orbit and puts you right back to embrace your new mindset, one rooted in power, perfection, and promise. And an absolute results are on the way, and hope you'll listen till the end of this video. And let's begin with today's topic on mathematical induction. This is related to MFCS DMS DMGT and intermediate 1A. And now in this video, using mathematical induction, we have to prove the following, that is A plus AR square plus and so on up to n terms, which is equal to A into r power n minus 1 by r minus 1, where n belongs to a natural number. So here, if you observe in the question, so nth term is not given. So you have to find the nth term first of all. So in the solution, first of all, finding the nth solution. So how to find this nth solution? As there is a formula that if AR square and so on are given, the nth term will be A into r power n minus 1. So you have to remember this one, the nth term. And now we have to substitute in place of nth term as A into r power n minus 1. So I have substituted the nth term as A into r power n minus 1, and this is A times of r power n minus 1 by r minus 1. Now we have to prove this statement using mathematical induction. Let S of n be the statement. First of all, according to the mathematical induction, we have to check with n is equal to 1. So we have to substitute n value as 1. So in the RHS as well as LHS. So in this equation, so this is LHS. So here LHS is very clear as A. And in terms of RHS, what is in RHS? A times of r power n minus 1 by r minus 1. So this is our RHS. In this, if you keep r is equal to 1 and if you cancel r minus 1, so again we got the answer as A. So LHS is A and RHS is also A. And we say that LHS is equal to RHS and our statement S of 1 is true. So in this, so this is the statement. So first, if you keep n is equal to 1, LHS is equal to RHS, and the statement S of n is true when n is equal to 1. So this is the first step in mathematical induction. The next step is we have to assume that S of k is true. So we have to assume that S of k value is equal to true, which means that in place of n we have to substitute k. So we have to put n is equal to k. And we have to assume that both LHS is equal to RHS. So wherever there is n, I have substituted k here. And therefore, we have to consider this equation as equation 1. Clear? And next one, in the third step, we have to show that S of k plus 1 is true. So we have to show that. As you know that the nth term of the equation is nothing but A into r power n minus 1. So what will be the k plus 1th term? So in place of n, substitute k plus 1. So wherever you find n, substitute k plus 1, and plus 1 and minus 1 got cancelled. And what is left over? A into r power k. So this is our k plus 1th term. Now adding k plus 1th term, that is A r power k on both sides of equation 1. What is our equation 1? So this is our equation 1 after keeping n is equal to k. After keeping n is equal to k, this is our equation 1. So this is our equation 1. So in this equation, I have to add this one. K plus 1th term. What is our k plus 1th term? A r power k. Now in this equation, I have added A into r power k on both sides of equation 1. Clear? And now what will be the RHS part? So this will be the RHS part. And now I'm going to calculate this one, and I'm going to show you that S of k plus 1 is true. So this is our RHS part. And now I am taking r minus 1 as an LCM. So this will be A times of r power k minus 1 plus A into r power k into r minus 1. So this will be A into r power k minus A. And if I multiply this one, so this is power 1. So this will be k plus 1 minus A into r power k by this value is r minus 1. Now I can cancel these two, that is A into r power k and this A into r power k. After cancelling, and see what happens here. So if I take A common, from these two, then what happens? So this will be r par, this is k plus 1 minus 1 by this value is r minus 1. So here, if you check here in the RHS part of the question, so what is there in the RHS part of the question? So this is the RHS part of the question I'm going to show you. This is a into, so this is a into r par n minus 1 by r minus 1. So this is nothing but the RHS part. So if you observe this RHS part in the question, so it is substituted by, so this is a here. In place of n, we have seen k plus 1, and same as it is minus 1 here, and here in the denominator it is r minus 1. So this is nothing but s of k plus 1 is true. So here, if you see till here, this is k plus 1th term. See a r square plus and so on, a r k minus 1, a r k plus 1. After solving this part, so after taking step by step, so we got an answer which is substituted as n is equal to k plus 1. Therefore, s of k plus 1 is true. So if it is true for n is equal to 1, if it is true for n is equal to 2, 3 and so on, k plus 1, and we say that it is true for any natural number, and therefore the statement is true according to the mathematical induction, that is a plus ar square plus and so on a r n minus 1, which is equal to a times of r minus n by a times of r par n minus 1 by r minus 1. So this is true according to the mathematical induction. And therefore, let me explain you once again, as it is so simple. So we have to remember this nth term, as the nth term is a into r par n minus 1. After substituting the a nth term as a into r par n minus 1, first of all we have to go with n is equal to 1. In the LHS part it is a, in the RHS part it is also a. LHS is equal to RHS, therefore the statement is true when n is equal to 1. And next one, we have to assume that it is true for n is equal to k. So the second step we have to take is put n is equal to k. In place of n I have substituted k, and I have denoted it as equation 1. And in the third step, we have to show that it is true for n is equal to k plus 1. So what is the nth term here? The nth term is nothing but a into r par n minus 1. In place of n, after substituting k plus 1 and cancelling, so k plus 1th term will be a into r par k. Now adding the k plus 1th term on both sides of equation 1. What is our equation 1? After substituting n is equal to k, we got equation 1. And after adding this k plus 1th term, and this will be the RHS part. And after solving the RHS part, so we have got an answer which is equivalent when n is kept as k plus 1. Therefore, it is true for k plus 1. So, therefore, it is true for 1, 2, 3, k plus 1 and so on. And therefore, it is true for every natural number. Therefore, the given equation is true according to the mathematical induction. Hope you guys understand this one. If you don't understand, go through this video for one more time. And if you really like, please raise your thumb, subscribe to this channel, pass it on to your friends, and stay connected, because so many videos will be uploaded very soon related to this series. Go to the playlist. Definitely you will be benefited, and it will be very helpful for your preparation. Thank you for staying till the end. Thank you so much.